What's going on, everybody? My name is Jigsaw64 and today we're going to be doing BoardLight from HackTheBox. This is of course an easy rated Linux machine where we're going to discover a subdomain that's running an ERP application that is vulnerable to a PHP code injection. Upon getting our shell, we're going to check out the application's database, grab a password, and switch to user. After checking out the SUIDs as user, we're going to find out that one of them is exploitable and use that to escalate to root. Let's do it! Alright, so I like to be organized and have everything in my HTTP directory. Let's make a new directory for BoardLight. And now let's enumerate all the services running on this box as always. So -p- for all ports, enumerate version, aggressive scan, and output the file to nmap.txt. And I believe the target is already copied, 10.10.11.11. So we'll let that scan run and come back. Welcome back. Looking at the results, I did not start the nmap scan in the right directory. So let's just go ahead and move that over to BoardLight. And looking at the results, I believe it's just two ports that are open. And that's going to be SSH on 22, running OpenSSH, and an Apache web server on port 80, running an Ubuntu OS. So let's go ahead and check out the web server as always, and I believe it was 10.10.11.11. So this is obviously going to be the web page of the box. Checking our WAPalizer, we're going to see that it's an Apache web server 2.4.41. No vulnerabilities with that. Let's check out the contact us page. So this request a callback could obviously be an attack vector for something. Let's just type in some default credentials here. Email address. Remember the name of this song in this video at email.com. Message is going to be 1980. I actually don't know the year this song came out. But anyway, let's go ahead and actually before we hit send, obviously let's fire up burp. So let's go ahead and see what we get back. And I didn't have intercept on. Okay, so... And it's the next day. Anyway, looking at the response, we do get a 200, but none of our inputs actually show up, and our response doesn't actually go anywhere. It pretty much just goes back to the same page, right? And this actually happens a lot on these boxes, as it's not actually meant to be the vector that you're supposed to go down. So, that being said, let's check elsewhere for our initial foothold. Taking a look at this index page, there's not a whole lot we can interact with. There's an about PHP, do PHP, and the contact page from earlier, but clicking on anything just takes you directly back to the top of the screen there. But the important part is scrolling to the bottom, you see the domain is obviously board.htb, and this initial domain is just set up to be a red herring. And we're going to need this domain, board.htb, in order to enumerate any subdomains. So let's add board.htb to our local DNS file so that we can run a subdomain dirbuster on it. So I believe it was 10.10.11.11, and that's just board.htb. And let's see what we can find. So when I first fuzzed for subdomains on this CTF, I used GoBuster, but GoBuster, from my knowledge, fuzz is based off DNS, obviously, for subdomains, and this is an internal domain, so it doesn't end up finding it to my knowledge. I'm sure there's a flag you can use, but I just opted to use FFUF, which is another fuzzing tool, and so it's same thing, -u for URL, and in our case, board.htb. Word list is going to be user, share, seclist, discovery, DNS, and you can try with the smaller list, but in my experience, it doesn't find it. So I'm going to use the -20 or the 20,000 text file, and -h for host. Hosts, obviously I've already ran this. Fuzz for the subdomain, and board.htb. So at first, obviously it's going to spam us, and I think this is because it's hitting us with a redirect or something. I'm sure IPsec can explain it better than I, but you can filter for size on the output of this. So we can filter out 15,949, which is what I opted to do. So -FS for filter size, 15,949. And as we can see right away, we do get hit with a 200 on crm.board.htb. So we did find a subdomain. So let's go ahead and add that to our local DNS file so we can resolve that. And you can obviously use VI here. I like to use nano because I'm a noob. But that's crm.board.htb. And now we can go ahead and check that out. And there we have it. So this is the Customer Relationship Management and Enterprise Resource Planning application, Dolibar or Dolibar. I'm not actually sure how you pronounce it. But the important part is the version disclosure right in front of your very eyes. And it looks like it's 17.0.0. So let's look for any exploits. This one obviously is going to have a exploit with a proof of concept for anything on less than or equal to 17.0.0, which is what we're at. So taking a look at the proof of concept, this is going to be a PHP code injection, and we can see more about the vulnerability here. Scrolling down, we get a technical summary with the CVS of 8.8 and a little description here, and it states that the Dolibar 17.0.0 with the CMS website plugin core enabled as an authenticated attacker, we can obtain a RCE via PHP code injection by bypassing the application restrictions. Here is the proof of concept showing the exploit. It looks like there is a test user with some basic authorizations, such as being able to read the website content and create and modify website content, or at least the HTML and JavaScript. It looks like the code is flagged as disabled when the lowercase PHP tag is used, but it looks like as soon as, and that's a typo, but as soon as you change the PHP tag to be uppercase, it bypasses the permission restriction, allowing for the PHP code to be executed. And let's see, it looks like the PHP code just is supposed to print the value of 2 + 2, which got denied when lowercase PHP tag is used, but it looks like it executes just fine when the uppercase PHP tags are used. And in this one, he's just gonna print out the name of the user here with the whoami command, and it looks like the execution works, and it prints out www data, right? So that is the RCE. Basically, it's not validating, it's only validating on lowercase PHP. The remediation is of course downloading to the latest Dolibar release. There are some references here as well, and disclosure times of when the vulnerability was discovered. The important part is that this exploit relies on authentication. You need to have some kind of login credentials. That is where Googling for default credentials is always important to at least try before you start fuzzing or brute forcing your way in. And it looks like if you didn't change it, login as admin, and the password is the same as the one sent by email for your dashboard access. So I'm just going to try admin, and that is going to get us into the application, at least at a low level, which is all we need for this exploit to work. Taking a look at the exploit, we can see that it takes a few arguments, such as the host name, user, password, lhost, and lport for the actual reverse shell. Let's take a look at the Python script, and my VM is going absolutely haywire on me for some reason. I don't know why it happened. It does that when I put my computer to sleep and come back. But anyway, so we're just importing the necessary libraries in order to make the HTTP request, the headers and whatnot. This is going to strip the protocol prefix on the request, I guess. And then we have the authentication information here for the request. This is the actual request. And wow, this VM is actually really bad latency on this VM right now. This is where the exploit kicks in. Here it's going to create the actual site with placeholder information. And then scrolling down, this edit page function here is what's going to be the actual exploit. If we scroll down, I believe we should see, yeah, so this is the actual exploit. So it's going to create it's going to make a request, log in, create the site, and it's going to edit the site with the PHP reverse shell there. It looks like it does work if it's, it doesn't have to be, the exploit's not bound to just be full caps on the PHP. You can just do one letter capitalized, and that looks like that works. But that's where the exploit comes in. So let's go ahead and grab this repo and put it on our system. So before we clone this repo, I do want to show how we can do this manually, as we already have access to the GUI clearly. So the script is going to send a request to the application, and it's going to take the parameters that we provided, which is admin. It's going to log in, create a website, and we'll just name this pwned, description pwned, pwned.board.htb. So this is going to be a reverse shell, so let's start up a netcat listener on 8001 instead of 9001, because it was actually over 8,000, not over 9,000. So let's go ahead and create a web page. The script's going to create a page. We'll name this pwned. It's then going to edit the source HTML, and I'm going to copy and paste this part because there is a script in the background that keeps deleting this, and I have to keep re-recording this part. But anyway, so normally this is not going to work. We're blocked from adding dynamic PHP, but this is where the exploit comes in. If we just change it to capitalized or whatever, it bypasses the validation. So let's save. And this is the important part. You got to show dynamic content. And we should have a nope, hold on, it was 8001, not 9001. Okay, so we get a hang there, and as you can see, our reverse shell did connect back to us. So yeah, I had to copy and paste this part because the script in the background keeps deleting it, and I have to keep recreating the website. But yeah, so that is what this exploit is basically doing. It's just doing it all, obviously, through the script and making the request there, which is slightly easier. So let's go ahead and do that as well, just to showcase both. Let's grab the script, and you can clone the repo like I said, but this is just one script, so you can just copy the Python file as well. So let's go ahead and add that. I'm going to name it pwn.py. Just there's something about renaming the scripts that makes me feel better about using them. Makes me feel like I made my own script. Anyway, so now we have pwn.py, and the actual syntax is going to be going back here. Alright, so this is why I have a transparent background, by the way, so I can see things like this in case I ever need to. Python 3 pwn.py http crm.board.htb, and that's going to be username admin, password admin, lhost is going to be 9001, and the port or lhost is going to be, I am sorry, 10.10.14.36 on 9001. Let's start up the actual 9001 netcat listener, and that should be good to go. So it's trying the authentication, creating the site, creating the page, editing the page, and we have our reverse shell. So that's how you can do it with the script as well. And now we are on to privilege escalation. Let's do it. So as always, when getting a reverse shell, we should upgrade it so that we can perform tab auto completion and all the other great things that come with a fully interactive shell. So that's just going to be Python 3-c import pty.spawn bin bash, and let's background the session stty raw minus echo foreground export term is equal to xterm, and we should have tab auto completion and all that good stuff. So now let's go ahead and begin our enumeration. Since we're just dub data, I'm just going to take a look at the home folder, and the only user that shows up is Larissa. That is obviously going to be the user that we compromise in some way, shape, or form. Dollybar obviously uses a database to store all of its information, right? So looking for the configuration file attached to the database should yield some results, and googling for the file path, it should be in, so it's going to be in htdocs/conf/conf.php. So let's go ahead and take a look at that. We can back up to directories, and there is the conf directory, and there is conf.php. It might be in... We might see something in the old, but let's go ahead and take a look at the new. Yeah, so as we can see here, we do get the main database user as Dollybar owner, and the password is serverfun 2023. So I am going to head and copy that, and I'll throw it in a text file. Wait, now hold up, I think I missed the exclamation marks. Yeah, so that's going to be server 20 fun 2023 double exclamation marks. So there is the password for the database. Now you can get into the database, but it's always best to, especially on the easy CTFs, to try and see if password reuse is in play, right? So let's just try and switch to Larissa, and that is also Larissa's password on the machine. So we can also SSH in as Larissa. Larissa, that's 10.10.11.11, I believe. It's 10.10.11.11. And my VM froze. Alright, and it's unfrozen. So I like to SSH in because it's a little, gives us the color, and it looks fancier. So let's go ahead and proceed on to gaining root level access on this machine. Before we try and escalate, guys, I do want to show the database real quick, as we could have logged into this MySQL database with that serverfun 2023 password. We obviously used it to log straight into Larissa since password reuse was in play. But assuming that that didn't work, let's go ahead and log into the database real quick so I can show that. So it's going to be MySQL, and my VM froze. MySQL, and the user was Dollybar owner, and we'll be using the password from earlier, running on I think it's lowercase l, localhost on port 3306. And I have the password copied, the serverfun 2023 password. Show databases. And let's go ahead and use the Dollybar database, the only one. And for sake of saving time, I'm going to paste the select statement here to select the user table. And this is going to show the bcrypt hashed passwords. The admin's going to, you can crack that, and it's going to be admin. obviously we logged in earlier using admin, and that's going to be the password. This one, I'm not sure. It could be the server fund 2023, but we already have that obviously. So I just wanted to show that in case you went that route. But obviously you can use the password to log straight into Larcissa, as it's also their password on the local machine. So now let's go and head on to escalating to root. Let's run a sudo-l to list any elevated privileges that we're able to run as Larissa. And it looks like we're not able to run sudo on this machine as Larissa. Since we're unable to run sudo as Larissa, the next logical step towards escalating our privileges is to check for any SUID binaries, and these are of course executable files that run as the owner of that file, regardless of who we are. So let's run a find command starting from the root directory for permission 4000 for SUID, and that's going to be of type file. And on that, for any file it finds, we'll run an execute command ls-l to list the file permissions, and we will then finally terminate that and throw any error messages to dev null. And the results are coming in slowly on this one. What the heck? So looking at the SUIDs, we do get a big hint based on the box name, and I don't know if HackTheBox only does this for the easy rated machines, but since the box is named BoardLight, it's a bit of a hint to take a look at this SUID right here, this enlightenment _sys. We can just do a search for enlightenment _sys, and right away you will see that there is an exploit DB article, which is always good as the first result, on showing a privilege escalation. And it looks like, yeah, so enlightenment _sys and enlightenment before 0.25.3 allows local users to gain privileges because it is set UID to root, right? And we can actually check the version of this file as well by running enlightenment version, and I misspelled it, so it's going to be enlightenment -- version, and as we can see, it is version 0.23.1, which does fall in line with this exploit here. There are some references here, as right here there is a link to download Enlightenment. Enlightenment is basically a desktop environment, a lightweight desktop environment for Unix-based operating systems, and Enlightenment Sys is a component of Enlightenment designed to do low-level system operations for Enlightenment. And let's check out the CVE as well on that. So CVE 2022-37706 states that the Enlightenment Sys in Enlightenment before the versions allows local users to gain privileges because it is set UID as root, and the system library function mishandles path names that begin with a /dev substring. So basically this binary fails to handle path names that begin with dev, and it's going to essentially be abused to concatenate a malicious command that executes a shell, giving us root since the binary has the SUID set as root. And we'll go over the script to see exactly what it does as well. So the author is null security, and scrolling down looking at the shell script, it's just going to print out some text, and here it's going to find the vulnerable binary and assign it to file. If the file is empty and it can't find it, it's going to let us know. If not, it's going to tell us that it was able to find the binary. Next, we're creating this net dummy directory that will be used later in the mount command, setting up the path traversal with the command injection point, creating the malicious script to spawn the root shell, making that script executable, printing another funny message, and this is the actual exploit that's happening. It's running the mount command, something that the Enlightenment Sys binary might typically run, followed by the execution of the exploit script that we created with the bash shell spawns, and since it's running as root SUID, it will spawn a root shell. Finally, it waits for us to press a key and eventually cleans up the files that it created. So let's go ahead and copy this script and just the things that we actually need here. And we'll just do nano, we'll call this pwned.sh, paste that in there. And this is the interesting part about this exploit, or maybe it's just with bash scripts, but I actually couldn't get the script to work with this command all on different lines. And I think it's just the way bash interprets multiple lines. You might have to do a / on each end. But basically this part all has to be on the same line for this exploit to work. Make the script executable, of course. Finally, we will run our pwn.sh script, and within 1 second, we have our root, and that is going to be BoardLight. Thanks for watching, guys. I'm Jigsaw64, and I'm new to pen testing and ethical hacking, and I'm on my journey towards OSCP. If you have any tips, please let me know. Until next time.